the increasing awareness on water scarcity in Mumbai was the prime motivation. And at the time at which we proposed the project, a new grey water treatment plant was installed in one of the hostels in IIT. And we wanted to study the characteristics of grey water and look at how well the plant was functioning. So that was one of the motivation. And we also wanted to look at alternative reactor configurations for treating grey water. So in this plant, they have numerous units. So there is an equalization tank, which is followed by a sequencing batch reactor. And this is followed by pressure sand filters, activated carbon units, and then 2 stages of disinfection, that is chlorination and UV treatment. So we were looking at, so this seemed like quite an elaborate system that should treat grey water properly. But we wanted to look at how this grey water variability affected the performance of this plant. And we also wanted to look at low cost alternatives. So here we were looking at only a novel RBC reactor, that is a rotating biological contactor, to see how well it could perform using the grey water from this hostel. So in this plant, as I said, it is an elaborate plant. So the grey water is first sent to an equalization tank after bar screens, and then that is sent to a sequencing batch reactor. The sequencing batch reactor is a biological treatment unit. So here microorganisms would be treating the organics in the waste, and this is then followed by filtration, so pressure sand filtration, which is followed by activated carbon units, which would remove traces of organics also from the grey water. And eventually this has 2 other stages of disinfection. One is chlorination and the other is UV. So it is being disinfected and then discharged, and this water is to be reused in the toilet flushing and for gardening needs in IIT. And our solution is a low cost system, which is just the biological unit. So we are changing instead of a sequencing batch, we are using a RBC, which is a rotating biological contactor. So in this unit, we have discs that are rotating at a low speed, and this aerates the system. And the novelty in this reactor is we have a non-woven fabric as a filter in the RBC itself. So we have this is a 3-stage RBC, in which the first 2 stages has discs and the biological treatment is happening. The 3rd stage is essentially a collection chamber, and between the 2nd and the 3rd stage we have a non-woven fabric filter. So as you have a biofilm developing on this fabric, you have better quality of filtered water that comes out. So it's a biological treatment come a solid separation unit together. But in our system, we did not have any additional units for disinfection, etc. So we were looking at primarily the removal efficiency of solids, removal efficiency for turbidity, and the removal for organics. Those were the objectives. Here we are using a RBC modification. Normally in the RBC, biofilm will slough off also. So some of the solids may get carried over with the effluent. So the beauty of this RBC is, instead of any settling tank, it has this non-woven fabric filter in the same unit, which is taking care of the settling requirement. So this is a variation of what is commonly the RBC process. It is not exactly the conventional RBC. This is a new prototype we are testing for grey water. Currently, our target audience was to bring to the IIT administration as to how the plant is functioning and the variability in the performance of it, variability in the characteristics. So, making IIT administration aware of the performance of the plant, that was the first thing. And also to make IIT residents aware of what is the quality of the treated water. Because there is another grey water unit that has been set up in one of the buildings, multi-story buildings, where it is only physicochemical treatment is being done, coagulation, flocculation and nothing else. And there the residents have shown a lot of reluctance in using that water because they are not confident of the quality. So we are trying to sort of show that what is the quality of the treated water and show whether or not it is safe to the residents also and to the administration also. At this stage, this was our objective. But subsequently, if this works well, it can be used in other hostels also. For example, currently the system given here is a more elaborate system. If we can develop this sort of low cost alternatives, that will bring down the cost of treating grey water. So those are the advantages. So there are very limited studies available on grey water, and this was our objective, to see the variability, because if the inlet varies, whatever your treatment process, the effluent is also likely to show variation. That is why characterizing is also very important. And not only that, characterizing will tell you how to operate your system, whatever system it may be. For example, the biological treatment, it needs nutrients if the nutrients are not already there. In sewage, nutrient is there, ample nutrient is there, nitrogen, phosphorus, etc. But in grey water, they may not be there. So when we started, we were looking at this level of nutrients in the inlet grey water. We found that they are pretty low. So that tells us that characterization is an important step. If we do not add, then the process will not work satisfactorily also. One of the key challenges in this type of a recycling is the variability in the inlet quality. We see huge variability in the inlet quality, where in any water quality parameter, the mean and standard deviation are almost equivalent. You can imagine how much of a variability that is. So this is what we are encountering, huge variability in the organic load. So whenever you have this type of variability, treating it poses a challenge. In terms of other challenges, see, I already mentioned, for example, the quality of the water will dictate how to operate the biological treatment units. That is a challenge, that often people are not characterizing the water. So when they are treating, they do not know what to add, how much nutrients to add, what is to be done. Because of this reason, this would pose a challenge. If nutrients are not properly added, organics will not be removed adequately, which is one of the problems in the current treatment plant in Hostel 10. That is one. In our system, one of the key challenges is that you have head loss development, which can happen because of development of excessive biofilm on the fabric. At that time, you may have to take the fabric off, clean it and then put it back, because as it operates, more biofilm will develop on the fabric. Initially, that improves the quality of filtered water, but eventually that will create head loss, and depending upon the freeboard that is available, your head will keep on rising on the upstream side, and you have to have adequate provision for spillways and all to recirculate that. So these are some of the challenges. Apart from that, in the other unit that we were studying, the one in Hostel 10, we find that there is no provision for sampling at intermediate time between units. So for example, between the sequencing batch and the next unit, for example, pressure sand filter, there is no way we can draw the water in between and test it. So all we can do now is, it is like a black box, we can sample the inlet and sample the outlet, but not at any intermediate point. This, I feel, does not let us understand how each unit is performing. For example, the carbon filter may have gotten saturated and may need regeneration. We do not know that, because no one is sampling before and after to see how much removal is happening in it. And there is no provision for sampling given. So I feel these sort of things should be taken into account when designing the systems.